Hello, welcome to this webinar, which is about data acquisition in our demo lab here. So I'm really happy to be with you. This webinar, it will be in three parts. So basically, there is first the company presentation, where I'm going to explain you who we are. There will be then the live demo with the system, which is just behind me, and then the Q&A. So first, let's start by who we are and who I am. I am Mathieu Marmion, working at Spekim as a lead application specialist, and I'm part of Spekim, which has been founded in 1995 and is a spin-off of VTT, the Finnish National Research Centers. Since almost 30 years, we have been able to deliver more than 10,000 hyperspectral devices all around the world. And we also have a global presence. So the headquarters is based in Finland, Oulu, where I am located right now. And we have also offices in the United States, Spain, Germany, and also China. We also have a big network of distributors all around the world. Since 2020, we are part of Konica Minolta. So now we are actually for the live part, for the demo part. You can see we are using the 40x20 scanner with the FX10 mounted on it. And this is our acquisition software called Lumo Scanner. So this software is only for data acquisition, just a reminder. So this is not like a tutorial about the software, but just I would like to explain here which parameter to tune and to take into account in order to make good data acquisition with the hardware, but also with the software. So first of all, you connect with the camera. Here it's going to be an FX10 between 400 and 1000 nanometers connected with the National Instrument Grabber to the computer. This is a camera link camera, but we also have the Gigi version. Once you are connected like this, you need to load the right calibration pack. Notice that here it has a serial number, so I will check from the camera 121 or 160, and it matches actually with the spectral calibration pack, which is here, the serial number, also the date. Notice that when the calibration pack includes FX in the naming, that means that there will be the automatic image enhancement routine, which is going to be run in the camera to unify the spectral calibration between all the cameras and also to correct the smile and the keystones. I will record the data here in the D drive. Notice that on this computer you have actually two hard drives, one which is dedicated for the software and another one which is like more dedicated for the data. This is the one where we save the data. It's important to have one dedicated like this because it avoids to have some drop frame, which is annoying. Because remember, this is a line scan device, so you need to acquire, like the image line by line. Then here you have the possibility to choose 3 bands. It's only for the visualization. Lumo Scanner, this is an acquisition software to adjust the acquisition parameter with the camera, but also with the scanner. And here you have multiple choice. So now I selected the lab scanner 40x20, but we have different type of scanners. So behind me, for example, we have the 100x50, but we have also some other ones, rotary scanner as well. So here I just selected the right one. Then below that, there is a name generator. Just here you have the possibility to choose if in the naming you want to have a timestamp, a counter, or just the name, and this is what I'm going to choose. Also, keep in mind that the software, Lumo Scanner and Recorder, as a default record only dark and white references, but and the raw data, of course, but it doesn't record the reflectance data. For the reflectance data, we have a plugin like here, and here we can choose to have, for example, the data in reflectance recorded in float or calculated in float. We have different type of plugins. We have one, for example, for radians or time-lapse, things like this. But here now we move to, let's say, the more like industry or the more like interesting page. So on the left-hand side, we have all the parameters which are actually related to the camera, the acquisition parameter. So all our cameras include shutters, all except the GX17, but here you can hear like shutter opening and closing. When it is closed, basically there is no light entering the camera, so you are basically recording the noise or the reading noise, the dark current, the dark noise, that's the way to say it as well, of the camera, because it's a sensor. Every sensor, they have a noise. Then here you have the possibility to adjust the frame rate, the exposure time, the binning, and also the triggering mode. I will explain a little bit longer after, like in 2 minutes, how to adjust the frame rate and the exposure time. First, I would like to focus on the binning. With this camera, with the FX10, the light is actually dispersed over 448 bands, but the optical resolution does not justify to have a too little sampling. So we actually recommend to use a camera with a spectral binning time 2. So it means that you don't have 448 bands, but you have effectively 224. And we recommend to use that way because then you can improve your signal-to-noise ratio. You can also do that in the spatial direction. So as a default, this camera is having 1024 spatial pixels. If you bin by 2, you will have effectively 512. The beginning is important because it actually improves the signal-to-noise ratio by the factor of the binning, so the square root of the factor of the binning. So here we have a binning 2 times 1, the square root of 2 is 1.4. So basically you can improve by 40% already by doing that the SNR of your data. Then here we have the detector view. With the detector view, you see basically the spectral axis and the spatial axis. Here this is a waterfall, so basically line after line you can reconstruct what the camera is seeing. So if I put my hand underneath, we see it appearing like this. Then here we have like the spectral plot. So basically this is like what you see along this line of the data acquisition. So here you remember you have basically the spatial axis and the spectral one. Basically we can do that as well. So here you can recognize actually what we see. We have the gray of the scanner, we have the slope, we have the blue at the middle, and again the same on the other side. So this is what we see. And here we have then the same but in the spatial direction. This is the spatial profile, again the slope of the gray, the middle, and the same on the other side. So this is how to understand, how to see what we have. Notice that the illumination which is included here with this scanner is based on halogen, which are AC powered but with the AC-DC converter. All right, and here on the right hand side we have everything which is related to the scanner itself, like the scanning speed, different scanning position. So here we have the possibility to move it forth and back, and then to define different relevant positions. So again, this is not a tutorial about how to use the software, but how to use the system, I would say. So then here, first, I will adjust some different position. I will tell the system where the white reference is located. So here we have the beginning of it. I put it here. Here I'm a bit aside of it. Here we have it. And here we can say the white reference is starting here. I set it up. Then I look for the end of it. I come back, which is here. So here we have the white stop. I set it. Then we can define where the sample is going to be located. By the way, we are going to scan a 50 euros banknote. But first, I will use my business card to adjust the focus and things like this and field of view. So I go back to the white stop. I was already there, and I move a bit further, and I will say the scan will start somewhere here. So target start, set. And then I will move until the end of the scan. Here, target stop, set. From here, I have the possibility already to adjust the field of view. So now we are actually having a field of view which is from here. We can see my finger on one side of the image until here. If I want to have a wider field of view or then smaller field of view, I can adjust the camera height like this, which is then increasing or decreasing the field of view. So if I go, for example, to this position, I have the camera which is lower. Now I'm using, for instance, a 38-degree lens, and I have a field of view which is then from here down to here. Once I have done that, I would like to adjust the focus. And the way to adjust the focus is pretty simple. I like to use my business card because it has some really like fine text. I can look at it like this, and I try to have the transition between the dark and the white as sharp as possible, as well with the text. So here we see that we lost completely the focus. And then I had it, but I went over. So I just need to adjust manually where the transition between dark and white is as sharp as possible. So here we have something which is pretty nice. You can see it here with the transition. They are pretty sharp, and also already from the waterfall, it gives an idea. Now that you have defined your field of view and you have also made the focus, the next step will be to adjust the integration time. And to do that, we move towards the white reference, we stare at it like this, and we try to have along the spectral axis a signal which is filling the well capacity but not too much of the detector. So here we are having a camera which is coding the data over 12 bits, so between 0 and 4095 in fact. And then if we put an integration time which is too high, for example here 7 milliseconds, there will be some saturation. We would like to avoid these kind of things. So if I put something which is too low, then I don't use the best of the camera in terms of signal to noise ratio, because it's the same as if I will open my eyes but not long enough to acquire enough photon to be able to really separate or to acquire good images. So here 4 milliseconds is a bit low. If I put 5 milliseconds, I will reach about 3200 digital number out of 4096. I think we can put 5.5 is going to be something quite relevant. Notice that here, from the spatial point of view, this is not exactly homogeneous. As you can see, we are having halogens here. So you can see actually where the spots of the halogens are located. Keeping that in mind, that when you do the normalization of the data, meaning, you know, when we are making like reflectance computation as a reflectance data, we always measure the dark noise but also the white reference. So white reference which is based on a Teflon like this. With a white reference, we actually measure what is the incoming light at different positions of the field of view, and this normalization is made at each position. So actually this effect is corrected. The only thing you could say is that here the SNR in the deep is not as good as it is here at the top. So integration time is now adjusted. Then you could think about the frame rate. Now we have an exposure time which is at about 5.5 milliseconds. So theoretically, the maximum frame rate you could use is 1 divided by about 6 milliseconds. So here I was thinking to use 100 frames per second, because it means that you acquire a frame every 10 milliseconds. That means that there is time between frames for the camera, like to handle the next one. So I think this is a good one, but you can change it from here. There is one aspect that now you have to take into account. This is the scanning speed. And to adjust it, basically, I take a sheet of paper like this, and I put a white circle at the top of it. And then I can make a preview. First, I will adjust it manually. For example, what happens if I move at 20 millimeters per second? We will see if the round object will appear as round. So here we can see that the scanning speed is a little bit too fast because the round is not round anymore, it shrunk. If I put something which is too slow, it will be looking like an egg. So for example, if I put this time 10 millimeters per second and we make a preview, we will have a very elongated object like this. So in some application, you would like to do that so that in terms of pre-processing, after you have acquired the data, you can make like this a merging of data together. So you can compute like average frame, like shrinking things together. Typically, we do not do it, but you have this possibility. Notice that if you want to find the optimal speed, you can try different one manually, or there is something called aspect ratio, and then you can click on it, and automatically the system will propose you like an optimal scanning speed. So to do that, you need to put something dark and round at the top of something white, or the opposite. a white round at the top of a black support, and then it will compute for you what is the correct speed to have a correct aspect ratio. So here it proposes either to change the scanning speed or the camera acquisition speed. So here I would change the scanning speed. Then we can try again with a preview. And now we have a round which is looking round. Okay. Now we can take it back with us, and we are almost ready to make the data acquisition. Notice that when you want to make a really good data acquisition, we recommend to have the white reference which is located exactly at the same level as the sample. Like this you get really better absolute reflectance values. So I can put the sample now on the tray. I will define again where is the target start and the target stop. So I will start with the target start to check if we're at the right place. Then I will move to the stop, somewhere here, set. Notice that part of the sample here was saturated. So I can decrease the integration time, or I can consider that it's not so dramatic because I'm not interested in those areas. So in that case, I would say this is not dramatic because I'm not interested in those areas specifically. So I will do that. And here I will set up the system. So indeed, I want to record the white area and also to take the dark reference. Notice that for the white reference data acquisition, you have the possibility to either not take it, to be always to take a certain amount of frame in the white start position. You can make a scan between white start and white stop, and also you can make it manually by putting yourself a white reference under the camera. Here with the scanner, I prefer to use the area scan because then if there is a dust on the white reference, there is a possibility that when you scan it and you compute the average, or the software computes it for you, these dots will somehow vanish with the averaging. For the white reference, it's always better to keep it clean all the time. If it is dirty, you can use first an air blower, or you can sand it with a sandpaper to make it like to remove like the dust which is encrusted in it. So once you have done that, you are ready to acquire the data. We can then give a name. It's going to be bank note. And then we can say with operator, it's me, and then we are ready to acquire the data. So here I press record, and we have the data which is acquired. So first the dark reference with the shutter, then the white reference, and then finally the data. So here we see the banknote which is appearing, the area which is saturated but not our interest. Here you can notice if you got actually some drop frame or not. And then we have the possibility to open the data with our SpecIm Insight, which is our processing software. Here you have the possibility to set the directory. I can double click on it, and then it will go directly to Explore. And here we can have a look to the banknote. This is how it looks like. We can actually zoom on it down to the pixel level. Here I can make a rotation if we wish, like this. And then we can also change, for instance, the dynamic or the visualization, like this. And then it's possible to look at the spectrum in different areas. So for example, here I could make a square, and then we could see the spectrum related to the square just over here. So as a next, I would actually change the lens. So now we have made a data acquisition with a 38-degree lens. We had a field of view which was about 10 centimeters. 10 centimeters for 1024 spatial pixels, meaning that I had a pixel size which was about like 100 micron. So I'm going to change the lens to use a brand new VNIR macro lens. Okay, now we have been like swapping the lens. Now I will make a measurement basically with a brand new VNIR macro lens for the FX10. For, I repeat, a sampling on the sample which is about 10 micron and the optical resolution between 15 and 16 micrometers. So everything is the same, basically, the way to connect the camera, the way to connect with the scanner, to adjust integration time and things like this. Just to show you, so here again, I would have the white reference. We go again over there. So we see that here with this lens, we may need to increase the integration time. So for instance, here, I will put it around 8 milliseconds. It could be even more, but then I will have to have like a frame rate which is much slower. So for example, if I put here 75 frames per second, I can put here something like 12 milliseconds. Then after that, I can adjust the scanning speed. So here we're going to put 0.75 millimeters per second, like this. For adjusting the focus, this time, I prefer to do it, let's move a bit faster, I prefer to do it by adjusting the height of the camera, like this. So here we are not on focus, here we are on focus, and here we lost it again. When we have really like macro measurement like this, we have to consider that the depth of field is very, very shallow. So you need to have an object which is as flat as possible. So I have defined some target start and target stop. We can make a preview. Then I can readjust the focus if needed. Here, we actually have something which is really, really good. So I will wait that the preview is actually going on. And then after that, I will be able to make a data acquisition. So you can see here that the pixel size and the spatial resolution is really, really enhanced compared to everything we have seen, especially with the standard lens, but it's not for the same type of application. So here, I will go to the capture windows, and then I will be able to acquire the data set, macro, like this, and then a record. And as before, the workflow is working exactly the same way. First the dark, then the wide for data normalization, and then the data. I can actually change already from here a bit the brightness and the contrast. So as you can imagine here, now the scanner is moving really, really slowly. So that's why it's really important to have really accurate stepper motor inside the scanner, which is here, which allow you like this to make macro measurement, and also that nothing is shaking. You need to have a really high stability, and I have to say here our scanner allows these kind of things. So the data have been acquired, and then we can look at it again with insight. So you remember here it was basically with the normal lens, the standard one. Now if I open the one we just acquired, we can really move into the data and we can see a lot of details. And again, for each of the pixels, you can have a continuous spectrum like you have in here. So this is a resolution you can get with our brand new macro VNIR lens. I hope you enjoy this live demo. About the bundle, as you can see, all the demo was made with this one. So it includes a 40 by 20 scanner, which is here, where you can put samples as large as 40 by 20 centimeters, an FX10 or an FX17. And also, it will include, software-wise, Lumo scanner for data acquisition or SpecIm Inside for data processing. As you saw, we have multiple lenses available to match different needs. So for instance, the demo was made with two lenses, the one which is right now mounted, which is a 38°, which is a standard lens, and also the macro lens for VNIR spectral range, which is just here for really, really best spatial resolution. Please remember, pixel size 11 micrometers, optical resolution 15, 16 micrometers. If you want to get a quote or more information about this bundle or all our product in general, please contact us at info@spekim.com. You can also visit our website, and our sales team or myself will be happy to come back to you and answer your questions. Since we are talking about questions and answer, let's go right away for this webinar. Hello, so we are back. So I hope you enjoyed the presentation, which was pre-recorded. So I will be happy to answer your questions. So I see that we have already few of them, a bit less than 10, but please, you can still go on writing them, and I will go through. So let's start. It's always good to start with the first one. So let's start with the first one. So it was, do you need to take a new white-black reference for each scan, or can you reuse the reference between scans? It depends. It depends what you want to do. It depends on what you want to test. So if you have you have to understand why, first, you need to understand why you take the white reference and the dark reference. So the white reference, you take it if, for example, you change your illumination or things like this. So basically, the white reference, you take it to measure the incident light. So if you change your illumination or the integration time or things like this, or if the ambient light may play a role in the incoming light, then you should take it. So dark reference is more related to the sensor. So when you actually change the integration time here again, or if you change any parameter in the camera, or the temperature, which is surrounding the camera, it could have an effect as well. So then you should take it again. Typically, if you work with the lab scanner, I would say why not to take it? So then you use it for the normalization, or free not to use it, and you can use one you have recorded before. But this is true, when you are playing with industrial application, you may take the white and the dark reference at the beginning of the shift, and then it needs to work like this for 8 hours or even more than that. So it depends what you want to do, it depends on what you want to test. Regarding the halogen light, we can observe varying intensity. Could this affect the spectral data? For instance, if we aim to perform quantification analysis, will there be some issue? So about the halogen light, you have two types of varying intensity. Did you mean over the time? So that means that here you basically power the halogen with AC current. So indeed you have a flickering effect, which is matching, the intensity, the frequency of the current which is coming, the alternative current. And then here, yes, it will have an effect. Or do you mean spatially? So it means you can see some variation, you have brighter spot, darker one, brighter one, and so on. So here it depends how you make your normalization. If you do your normalization line by line or pixel per pixel, let's put it that way, then this is corrected, this is taken into account. So if you have a brighter spot, it means that along this line the SNR will be better than when you are in a deep of illumination, if it's darker. And this, the effect will be not as pronounced. So it depends what you mean. Is it working with RGB LED background and food industry for shell and kernel separation? So it could work with LEDs, but RGB ones you have to be careful because LEDs are recommended to use hyperspectral ones, so meaning they cover the full spectral range. With RGB LEDs, the problem you can have is you may have good signal for the red, the green, and the blue, but nothing in between, or very poor signal in between. So then you cannot measure a spectrum. And if you want to separate, for example, shell or kernel from something else, the spectral information will not necessarily be in the RGB bands, because if they are, then no need to use a hyperspectral camera. So then they need to be in between. So here you cannot use RGB LEDs. You need to use hyperspectral LEDs, and there are suppliers for that. So if you need more information, please contact us. We can help you in choosing the right LEDs. What is the max scanning speed? I have to say I don't remember exactly the manual by heart, but for the 40 by 20 scanner, I think it is 100 millimeters per second. That's what I recall just out of my memory like this, but it can be double checked from the manual. About the macro lens. Is this the new macro lens? Yes, it was the new macro lens for FX10. Be aware, by the way, we have an old one already for the FX17. So it means that now you have possibility to have a macro lens for FX17 and also for FX10. For FX17, the pixel size will be about 20 micron. For the FX10, the pixel size will be about 10 micron, and the effective spatial resolution will be about 15-16 micrometers. The smaller defect that could be detected, I'm used to say it's about 2 to 3 pixels. So here you are sure to really be able to detect your defect. So pixel size 10, resolution, sorry, 15. So I would say about 20 micron, you will be able to detect it. Yes, this is a new macro lens. Yes, I already did. And which factor can affect the white-black reference, temperature, etc.? Okay, so I think I already gave a kind of answer, but I can repeat again. About the white reference, it sees mostly the illumination. So it is actually seeing the illumination, so incoming light. So what can affect it? It is if you change any camera parameter, for example, like the integration time. Normally changing the frame rate should not affect that, but I always recommend that if you change the frame rate, then you should also take again the white reference. If you have the ambient light, which is having an effect, and also if you have a camera which is sensitive to the ambient temperature, not really the FX10, not that much the FX17, but then the one with longer wavelengths, it has a significant impact. So then here, that will have an impact as well on the behavior of the camera. So if you have an effect on the dark noise, somehow you will have an effect as well on the white reference, which is measured. How to solve the warning message, get next frame, one frame error. So here, please contact us, and our support team will be happy to answer this question. I do not remember what is the warning related to that one. Should we switch off the light in the room while analysis? When you analyze the data, I would say don't do it in the dark. But when you acquire the data, that might be wise. So it's always good, especially if you want to make something very accurate. So for example, for color measurements, yes, I will recommend to do that in a dark room with ambient light off, because the ambient light will have an effect, especially in the visible part of the spectrum. Between 900 and 1700 nanometers, it depends on the ambient light you are using, but really it depends what you want to do, how robust the system is compared to the ambient light. So if you are using the 40x20 scanner and your application doesn't really require to be super thin in the depth of the peak and things like this, for if you want to sort some plastics from each other, and they are really spectrally different, so I would say it doesn't really matter. But if you want to make a quantitative analysis, then it could matter. So I would be careful. So color measurement as well, please turn off the light and be in a dark room. Can you tell the price for the new macro lens? I can, but I will not, because we have actually competitors with looking at this webinar as well. So if you are interested by this new macro lens for the FX10, please contact us. And we will contact you as well. So here we have Harry telling me we will also contact you. Next question. Are the dark and white rays stored inside the data cube generated through the scanner? If yes, do they always have the same coordinate? No, they are not stored inside the data cube. So basically, when you use Lumo scanner, it will record 3 data cubes. It will record the one for the data, one for the dark, one for the white. And here you can actually choose the size you want them to have, like how many lines could be acquired. With Lumo Recorder, you can choose. Could be in a separate data cube, or then it could be embedded. I don't recall if it is at the beginning or at the end, but I think it is at the beginning. At the end, in the case of Lumo Recorder. Yes, here. Is it not possible to increase the capture speed of the FX10 on the camera link mode over the Gigi model? Hold on, I need to read that again. Isn't it possible to increase the capture speed of the FX10 on the camera link mode over the Gigi model? Okay, I get the question. So basically here with the FX10, this is true that if you use like camera link or Gigi version, you don't have a big difference in terms of like a maximum frame rate. It's about 320 frames per second or 330 for the second one. So that's true that it's really close. So that means here that the data rate provided by the FX10 is not over basically what the Gigi can provide. If you want to increase the speed of this device, you can make a region of interest, so you don't have to read all the bands between 400 and 1000 nanometers, and then the camera would get faster. But this is true that Gigi or camera link will not have a big difference. For FX17, this is different. The camera link is faster than the Gigi camera. In the documentation, it doesn't show that the FX17 increased the maximum capture speed, but not on the FX17. Yes, it's what I explained. Hi, sometimes I have a very low dark signal, but the white reference is almost over-illuminated. Do you have a hint how to deal with this? So sometimes I have a very low signal, dark signal, but the white reference is almost oversaturated. Yes. So here we recommend actually two approaches. Either you use a white reference, which is not white, use what we call a gray reference, which could be like 50, 70% or 25%. And here you could use that as a white reference. So then, of course, in your normalization formula, you have to take this into account. So, for example, a signal which is 100% reflected over a 50% dark reference, a white reference, that means that actually it's only reflecting absolutely at 50%. But you can use this approach. You could also use a double integration time approach. So it means that you acquire your data and the related dark with a certain integration time, which is typically longer, and then a white reference and the related dark with a shorter integration time. And then here in your formula for the reflectance, you need to make the ratio of the both integration time to give the absolute reference in terms of signal level. You need to make the assumption that the signal is linear, also different integration time. That's how it is. So you can use those approaches. Is it possible to scan continuously, or must the camera return to starting position? It's jumping when I get a new question. Sorry, I lost it. Is it possible to scan continuously, or must the camera return to starting position in order to start a new scan? To elaborate, can the target ends be set as targets that once the scanner reaches it? Yes, in the way that the scanner is working, the software is working, before to start a new scan, it always goes back to the home position, to the initial position. This is the way the workflow is set in Lumo Scanner. So, in fact, we have a plugin, if I recall well, which is more internal for demo scan, that it's moving constantly. But, well, okay, you can contact us and then we can discuss. What is the calculation done for spectral and spatial binning? It's averaging. So basically you have two pixels next to each other, and then when you do spectral or spatial, then it is an average, which is the results. When I use Speaking IQ custom model, some reflection value were larger than 1. How to solve that problem? So here that means basically you may have a sample which is over reflecting. So that may happen when you have like specular reflection compared to the where actually the white reference is located. That means that the white reference is not the brightest object. So either it is on shadow, if you think that you're on a scene outside, like you can have the white reference which is located on a shadow and the sample which is exposed more to the sun or something like this. How to deal with that? So place the white reference in a way that it is effectively the most reflective object. That will help you. But I know that in some cases it's difficult when you have specular reflection, some objects which are super bright like mirror. So here there's not that much you can do. Maybe to use like some filters to get rid like this of the specular reflection. But yes, that's what comes to my mind. I know in some cases it could be really difficult. Are there any studies, data sets on how out of focus influence the results? I want to use a sensor while walking over some time throughout terrain. when you are out of focus, there are not really the articles about that, but then you just need to think about how it works. When you have something which is out of focus, it means that the transition between the object is not sharp. So in those transition area, basically the pixels, the spectra you get, they are mixture of the surrounding and the objects. So this is what you have when you have the transition, like the surrounding and the object. The middle, if it is homogeneous, it doesn't matter if it is on focus or not on focus, you get relevant spectral information from this part. But if you want to measure things which are like located far away, you can focus the camera at a certain distance. It depends on the camera, sometimes like 5, 7, 10 meters, and then everything which is further away than that will be on focus. So you can adjust the focus in such a way. But yeah, so this is what I can comment about this question. Okay, hi, great demonstration, very helpful and insightful, thank you. For forensic investigation purpose, focusing on body fluid investigation on different substrate, do you recommend speaking IQ or FX10? Well, first, the spectral range I think is the correct one. It's between 400 and 1000 nanometers, because when you have fluids, especially body fluids, they are mostly like, you know, with water, and water absorbs most of the signal after 1000, 1200 nanometers. So then, okay, first, VNIR spectral range. Then it depends how you want to use it. IQ is very good when you want to bring the camera to the scene. You know, it's a portable device, very easy to use in that respect. So if you need to go where you have the crime scene, use the IQ. I recommend to use that. If then you get some clothes and you want to measure like which type of body fluid you have in there, you could put them then on a lab scanner, like the one I was using, the 40 by 20, and then you can use the FX10. So this is the way I would recommend the usage of those cameras. Do you know how will the device respond to different substrate as a scanning background? For example, fabric type, glass, metal, and plastic. Is there any recommended parameter for forensic imaging? Also, is it possible to acquire an average number for the spectral data at a certain area of interest? Well, then here, it's a bit difficult to answer. We know that some of the body fluids, they have some spectral response between 400 and 1000 nanometers. We know that some substrates, they have some other one. When you mix together, it might give something else. So we don't have really like spectral response. We don't have spectral library to provide, but typically you are free to make your own research and to use like the camera and to build your own spectral library. Of course, then about the data processing, if you want to make like too slow scan to have elongated image, and then if you want to merge those averaging to improve the signal to noise ratio, it is processing. This is the way you want to process the data. It's up to you. So it's possible to do that and to average a number from spectral data and things like this. So that's the way you want to proceed. This is not, our camera doesn't prevent to do that. If you want to do it, you can do it. Is it possible to use this camera outdoor with sunlight illumination? Yes, actually IQ or FX10 or FX17, even the Sphere camera, the long wave infrared, the FX50, all our cameras could be used outside, outdoor. And actually, I must say that the sun is a pretty good illumination, especially like between 400 and 1000 nanometers, because you don't have so many absorption bands from the atmosphere. Well, you have some, but they are not like critical. And then you have actually quite good blue light compared to the red one. So if you use halogen, this is a little bit the hiccup with it, is that you have good red and IR illumination, but not that much in the blue end. With the sun, it's much better. But you really have to consider, and already spoke about it, you have the sun which is here, your sample which is here, and in between, you have a quite long path, and then you have the atmosphere. So the atmosphere has some absorption bands, and you have to take that into account. So for some wavelengths, it doesn't really matter, but for some others, like between, for example, 3 and 5 micrometers, or between like even 1000 and 2500 nanometers, you may have some really strong absorption bands. And also when you do that, you have to take into account that you may have a cloud. And a cloud, at the end of the day, it is like a water filter. And water has some very strong absorption bands as well. So you can, but you have to take into account those parameters. Is it necessary to use white and dark reference during the scanning process every time? Can it be added as a calibration? Yes, you can do that after. I mean, like, you don't need to take the dark and the white reference before. You don't need to take it every time. You can capture it once and then use those ones and to be used again for the other data sets that you have acquired. But again, it's what I was explaining. You have to be aware that the dark and the whites, it depends as well on the environmental condition when you are making your measurements, integration time, frame rate, if the light has changed, if the temperature has changed significantly. So yeah, but it depends on what you want to do as well. It depends how on thin ice you are working, spectrally speaking. So if you need to make really like, if you need to see really small differences in your spectra, so it might be good to take it every time. If you don't need, then, well, you don't need to take the dark and white reference all the time. Can we use the camera above a conveyor belt, so without using the camera motor? I guess, well, okay, I will not guess. I will try to answer everything. So FX10 and FX17, there is no motor. So yes, those ones, they have been designed to be work for industrial environment, so it could be at the top of a conveyor belt. The other ones as well, by the way, like the Sphere, the FX50, and also the FX120. So they could be used at the top of the belt because they're actually line scan device, and you remember you record spectra like this, line by line. With the IQ camera, that's the only one having a motor. So here the scanner is included, so you don't want the sample to move at the same time you are actually recording the data, otherwise the shape will look a little bit funky. But so for the one which are purely line scan, I would say you can. For the IQ, I would not recommend it. Does the plugin reflectance have this in account when using gray reference panel? Yes. In the latest version of the plugin, you can set actually what is the reflectance level of the white reference tile. So yes, it can be taken into account. For those who do not know, with Lumo Scanner, you have the possibility to have plugins. So as a product, as a nominal product, it can record data, so the raw data, the dark and the white references, and that's it. But we have a set of plugins. So for example, the reflectance plugin, which could compute the reflectance data out of those. We have the radiance plugin, so if you have a radiometric calibration, then data will be also converted into radians. And we have some other one. We have, for example, time lapse. So if, for example, you want to record, I don't know, the same sample 50 times every 20 minutes, you can do that as well. You can set up like this a sequential measurement approach. When I use the Spekim IQ custom model, some reflection value, I already answered that one. Sorry if sometimes I mixed up a bit. Is a double integration time approach possible for the FX50 Lumo scanner, which automatically acquires a white reference? Actually, with FX50, if you are working with black plastic, I would really recommend to use like this a dual integration time approach, because black plastic, typically they have a reflectance which is about 4–5%. So it feels a bit stupid to use like a short integration time, you know, based on the white reference, and then you capture almost no signal from the black plastic, so the SNR could be poor. So with the black plastic, I strongly recommend to use the dual integration time approach. The Lumo scanner doesn't have this feature as such, but you can record first, you know, your data set with a certain integration time, with the white and the dark, and then you can record it again, or then only the dark and the white with a shorter integration time, longer integration time. So you can do that, like 2 scans, or focus only on the white and the dark reference to acquire separately. But yeah, for the FX50, I recommend to do that. How to select the plant region of interest for analysis is an introduction of Spekim Insight software. About Spekim Insight, we actually had a webinar last year. Last year or some time ago, and actually Harry sent the link. So we had a webinar, and there I was showing that within Insight, Within the Explore view, you have what we call a calculator, and from the calculator, you can actually already get like some indices like the NDVI, the T-carry, and things like this that you can apply on VNIR dataset related to plant. So here we have that already available. So Insight will help you with that. How many output signal we can get it from single camera is possible to 20 different delay time outputs? Sorry, I need to read it again. How many output signals we can get from single camera is possible to 20 different delay time output? Okay, so here I'm a bit confused. So please contact us, send us an email, because I do not understand the question. I do not understand what you mean. Are there old webinars available to watch? Yes, actually, I think Harry sent the link. I want to hire a Spekim IQ in the UK. Is it possible? And what will likely be the arrangements? Please contact us, and then our sales manager will contact you, and we will see the different options. How can your spectral library be used? File format, wavelengths, etc. At Spekim, we do not provide spectral library. We provide cameras and the software so that you can acquire the data and also to process your data. But spectral library as such, we do not do that. We do not provide those. So you can build your own, and then you can save it in the format you wish. So it could be like a CSV, it could be also the NV format. They have like a spectral library format. But we do not provide library as such. Do Spekim have spectral library to share or comment to interpret? No. So I just answer. So basically, we don't have spectral library. Paper blocks the spectrum of other material. Is there a specific thickness that limits it? So paper blocks the spectrum of other materials. So I don't know what you mean, like if you are working, for example, in terms of like transmission or things like this. Is there any specific thickness that limits it? If you think about penetration, because you have to think like hyperspectral imaging is a surface measurement method. So the longer you go to some wavelengths, the more you can see through your samples, but still it's a surface inspection. But it depends also on your samples. If you're looking at a fruit, if you're looking at meat, if you're looking at opaque samples. So yes, so the thickness of what you want to measure has a certain limit. I'm not sure I answer the question, but that's what I understand from it. Is it possible to combine acquisition with FX10 and FX17 at once? Yes, we have this dual acquisition possibility. For example, on our 40x20 scanner, you can put the camera side by side, but then they will have a field of view which will be like this, like not overlapping exactly, or one after the other, and then the field of view will match better. So yes, there is this possibility. We recommend to use actually two computers, one camera for like one camera and another camera, and another computer for the second camera. And then yes, we have like a custom version of Lumo Scanner and Lumo Recorder, which are working together. Lumo Scanner will work as a primary computer, like to control the scanner and one camera, and then Lumo Recorder will be the secondary computer triggered by Lumo Scanner. So yes, there are possibilities like this. And by the way, on our big system like Sisu Rock, all the cameras which are mounted on the system acquire the data at the same time. So on different computer every time, to not to lose any frame or things like this. But yes, there are possibilities like that. Is it possible to detect plastic under an organic leaf, for example, tobacco? I would say with the VNIR spectral range, no. With the SVIR spectral range, I haven't tried, but I would suspect that you will see some differences. So with the SVIR spectral range, you have a better penetration depth. So if you have like a leaf of tobacco and then you have underneath a piece of plastics, I could imagine that you will see some differences. Yeah, but then no more than that. And it depends how thick is the leaf. But I would think like one leaf might be possible. is it possible to implement SPECIM FX10 or FX17 with incremental encoder, conveyor belt for spatial referencing? Yes, actually, you can actually use the FX10 and FX17 at the top of a conveyor belt, and you can do external triggering. So we can provide it with the SDK, and then you can make your own software for data acquisition. You can externally trigger the camera, both of them, with TTL pulses, so the length and the intensity of the voltage, it is in the manual, so that you can come back to us and then we can give you all those information. But yes, you have this possibility, and also Lumo recorder could be triggered externally. So then, yes, you have those possibilities. Do you have more questions? Or I think we got quite many today, so that was good. I wait a little bit, maybe 5 seconds. It seems we don't. So I would like to thank you. Thank you very much for taking part to this webinar, this very active Q&A. I have to say you were really active. I did not have so many for like some times. So thanks a lot. So there is another one. There are companies promoting snapshot HSIs. What are the disadvantages of snapshot HSI in comparison to line scan HSI? Snapshot HSIs, you have to consider how they work. So first of all, if you snapshot, you have to think like if your target is moving, but it's not really suitable because you may have like pixel mixings, like wavelength mixing. So for example, if you have like an object which is like this, you start to acquire some wavelengths, and if it moves, then it's kind of a mix-up. So you may have the scan like this in the spectral direction. Then otherwise it could be like with macropixel or with lenslet. So that means that here typically the spatial resolution, the spectral resolution is rather low. So this is what you can, one of the drawback. And also in comparison with the line scan device as we have, is like it's more difficult to control the illumination over an area than over a line. So for industrial use, it's a bit difficult. So with the line scan device, you can use them in every type of situation. So if you have a fixed target, then you can have a rotary scanner. You can have like a moving target, like with a conveyor belt. So it can adapt to all type of situation. With a snapshot, it's a little bit more difficult. Is it possible to calculate the data cube size to get same size dark reference data cube? Yes, you can do that. So basically the typical size of a data cube in terms of megabits in terms of bytes, it is the amount of pixels per line times the amount of line you acquire times basically the amount of bands that you have. And then if it is a 12-bit camera, then you need to code the data over like 2 bytes. So you have to take that into account, then you do the math, and then you get the size of the cube. How to transfer the image to NDVI image, any protocol? So, well, basically, if you use Insight, there is already a pre-formula for NDVI data conversion from VNIR data. Is there a standard setup for gain thickness in grain? For grain thickness in grain. No, there is no standard setup like this for grain like cereals. Either there is like a thickness. But anyway, so the camera, especially the FX17, is really suitable to look at grain and different properties such as like moisture, starch content, and things like this. But then you have to make your own like a spectral library again, like if you have a healthy or not healthy grain. So yeah, those are the camera. In an industrial application, how frequently or at what interval would you recommend acquiring the white reference? If you have a system which is robust with ambient illumination, stabilized in temperature somehow, you put the camera in a temperature stabilized casing, and the model that you are building includes some pre-processing steps which can accommodate a little bit of light variation in intensity, you don't need to take it that often. We have customers who acquire it only like once a month, sometimes every second month. Some other ones acquire it once a day. So it depends of your design of your machine, and it depends as well of your design of your model. so how robust it is and what it takes into account. Does the type of the lighting affect the quality, e.g. the use of halogen lamp or LED, etc.? Well, then yes, you need first of all to use a light which is suitable for hyperspectral imaging, because you have to remember that when you measure with the camera the reflectance, you need to have an incoming light which is covering the full spectral range, because if you have an incoming light which has some dip or some hole within the wavelength, within the full spectral range, but you cannot have reflected light at those wavelengths, so you cannot measure a spectrum. So it's important that you have a light which is suitable for hyperspectral imaging. So halogen are good, between, for example, 400 and 2500 nanometers. For some longer wavelengths, you want to use thermal illumination, which is based on like hot radiator. So this is what we can use. But then you can use also LEDs, which are dedicated for hyperspectral imaging. You can find more and more of those available out of the shelves on the market. So yes, you could use this type of thing, but yes, it has an impact. Out of curiosity, if we combine the red, green and blue band with this hyperspectral camera, do we get the same image as the one obtained with RGB1? So, well, first of all, you need to consider a hyperspectral camera which is between 400 and at least 800 nanometers, so a visible spectral range. If you take some other one, like which is going more to the NIR, to the infrared, you are making what we call false RGB. So that means that you allocate to the red, green and blue some wavelengths which has nothing to do with the visible red, green and blue, which is basically at 450, 550 and about 670 nanometers. So if you have a data cube which is covering between 400 and 700 nanometers, and you put, for example, the blue at 450, the green at 550, and the red at 670, it will be very close to what your eyes do see. Then about RGB cameras, I would say it depends on the model you are using. Some of them, it could be just one band like this, 450, 550, 670. Some other ones, they could have instead not just a band, but a door, something like this, centered at those wavelengths, but then taking into account a little bit before and after. And some others, they can even simulate your eye sensitivity. So it depends on the RGB cameras that you are looking at. But this is true. If you put 450, 550, 670 nanometers, it is actually quite close to what your eyes do see. Does the low DN values, digital number value, or non-uniform digital number value across the detector affect the readout of wavelength reading, as all samples on scanner bed are not uniformly reflecting light back? But here you need to take into account, so you are speaking about spatial non-uniformity, and actually here you could see on our scanner, because we have 2 bars of 3 halogen bulbs, so you have like brighter spot, darker one, brighter, darker, and so on. So this non-uniformity, spatially speaking, is corrected when you normalize the data. So basically you take the white reference, the dark reference, and then you normalize in respect to those. And then you do it line by line. So remember, we are using like hyperspectral camera, which are line scan device, and then you can process or normalize the data for each pixel along the line like this. So then you correct this type of non-uniformity. Then this is true that if you have less light, you will have a SNR, a signal to noise ratio, which will not be as good as if you have a brighter spot. But this is how it is. Unless you can use, for example, more uniform light, it's possible, but then it's more expensive. Or you can use diffusers or things like this. How to take into account the nonlinear response of the matrix to obtain the correct pleasure spectrum if the object of study is too dark. Here, if we measure a dark object, I would actually recommend to use 2 approaches. Instead of the first one, instead of using a white reference, I will recommend to use a gray reference. So instead of having a reference style which is reflecting the light at 100% over the full spectral range, you can get another one which is at 50%, 70% or 30%. It depends on the one you want to buy. Then here you can set an integration time which is actually matching better with your sample, so then you can capture more light. So that means that here you can improve your SNR. Just when you normalize, you have to take that into account. So when you do the ratio, what is reflected compared to what is income, you have to consider that if your sample reflects 100% the same level as your white reference, which is a gray reference, so that means that you need to take that into account for the absolute value of your reflectance level. That's the first approach. The second approach will be to use a dual integration time approach. So that means that here you take the white reference and the related dark at a certain integration time, which is typically shorter, and then your sample with a longer integration time, with a related dark at a longer integration time. And then you normalize with that, and then you need to make the ratio between the two integration time you are using. Here you need to make an assumption that basically the behavior of the camera is linear over those two integration time, or let's say over this response of the detector in terms of digital numbers. So this is how it is. What I would recommend. How to remove the effect of halogen lamp in the area you mentioned in the recording. Sorry, I have something in the throat. Okay, yes. I think I already mentioned how to correct that. So if you have spatial non-uniformity, that could be corrected when you do the normalization, pixel per pixels, like along the acquisition line. Does exposure time for the sample and the white reference should be same, or can we adjust it to avoid saturation in the image? It is exactly what I was explaining with the dual integration time approach. Here, this is exactly the same. Typically, you acquire the white with a shorter integration time that you want to use to acquire your data, or you can play with that. Is there any reason the lamp are located at top corner instead of above the object, as it creates some shadows around the round black object? Does it affect the final result or not? So here there are two things in the questions. So the first one is how typically you place your illumination when you do hyperspectral imaging. The typical way is you have the camera which is looking vertical, like my head here, looking straight. And then you can have the light, actually, as we have here with the spot. And then it's about 45 degrees like this. And then you can measure the reflected signal like this. This is a typical way, and this is actually how it is implemented in the scanner that you were seeing. So you have one line of light before and another one after the camera. So you have like this double-sided 45 degrees. Does it have an effect like if you have some shadows? But, so here you are talking about the round object. So it was for the scanning speed. So basically, in the best way, you are right, you should have a super flat object if you want to measure the scanning speed. So it should be actually a printed black circle on the white paper, so you don't have the shadow effect. Then in the real world, if you have samples with some profile, having like this double-sided illumination, you avoid to have too much shadow, but if you have high profile, it's difficult to avoid this kind of phenomenon. Is it possible to take measurement at different angles, or are the camera fixed normal to the surface? No, you can put the camera as you want, and there are actually applications which benefit of what we call specular geometry. So you can have the illumination here, going to the sample, and then having the camera looking directly like this, as if it will be in a mirror. So this is, for example, the typical way when you are dealing with black plastic when they are shiny. It is a typical way to deal when you have samples in general which are not diffuse, so that means that they don't have like the reflection in every direction, but which is really directional like this. So also, if you want to measure color, for example, it's important to know the angle, because when you look at a paint, depending on the angle where you are looking at, you can have different colors. So in some cases, it's important to be 45 degrees, 20 degrees, 10 degrees, or even more than that. So no, you are free to put the illumination and the light in the geometry you wish. And actually, I recommend you to test different kind of geometry for your application if you have something which requires it, I mean. Can we also send commands to set parameters and look image from hardware interface or even Ethernet and Modbus interface instead of the current software. So basically, with our camera, we have a SDK, a software development kit, and here you have the possibility to build your own software. So yes, there is a list of commands that you can just send to the camera via the protocol, via the SDK, and then you can set camera parameters such as binning, integration time, frame rate, and some other things. And then you can just get the frame, and then after that you can build your own acquisition software. So yes, you don't need to use the current software. How do lab airborne hyperspectral cameras differ from those in orbit? Well, first of all, the requirements in terms of vibration, vacuum, temperature constraint are not the same. Those which are in orbit around the Earth, they have really tough constraints already to go there and then to stay there. The environmental conditions are not the same at all as when you stay here for airborne. In terms of pressure, it's not the same. Then, for the airborne use, we are actually using, like a line scan device. So that means that when you are flying, you record, like this, the line frame by frame over the flight time. Typically, those which are in orbit, it's more like an area which is taken, 2D, 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 and then you try to make a mosaic out of that after that. So it's a little bit different as well. And also, the one which are located in airplanes, how can I say? You need to have a GNSS IMU unit just attached to it so that you know exactly where the camera is looking at. In a satellite, I'm not specialist, but I believe it's a little bit different because you know exactly what is the orientation of the satellite and things like this. So it's a bit different. By the operating mode, 2Ds or line scan, or if it is more like for the constraint. Is the macro lens adaptable to your other camera, and which ones? So the macro lens, well, first of all, we have two macro lenses. We have the one which is between 900 and 2500 nanometers, which is suitable for the FX17, GX17, and Sphere camera. Then we have the one, which is the new one, between 400 and 1000 nanometers, which is a VNIR1, which is suitable for the FX10. So here, this is what we have. Due to chromatic aberration, bands are not focused at the same focal length. Which band to choose to make image as sharp as possible across the full spectrum? That depends on the lens you are using. I have to say the ones that we have designed by ourselves, we have optical designer at Spekim, and we design them in such a way that you don't have chromatic aberrations. Then there are some other ones which are specified to work between 400 and 1000 nanometers, for example. And this is true that you could be on a super sharp focus at 400 nanometers, and then it's going to be blurry at 1000 nanometers, or then the other way. So here you have to make a trade-off. But those designed by our optical designer take this into account and you don't have the problem. Why radiance is so wavy? It was not radiance, it was actually raw data. So the raw data you were seeing with the FX10, it's true, it had a wave like that. And it is because, well, it takes into account, there are raw data. So first of all, it is a combination of the light, which is incoming, the reflection of the object, and the sensitivity of the camera. And the sensitivity of the camera results from the transmission of the optics with the sensitivity of the detector. In the case of the FX10, it is a CMOS detector, and the structure of the detector makes the raw data wavy like this. But when you normalize, those waves disappear. On average, what is the size of a single data set? What can I say? If you don't use the macro lens and you scan over the 40 by 20 scanner with a field of view, let's say 10 centimeters, and you scan about 30 centimeters long, just out of the sleeves like this, I would say maybe one giga. That's what it is typically. But it could be more, for example, with a macro lens. If you scan, for example, like 5 or 10 centimeter long, then it will be few gigs. But yeah, we are talking about gigs. That's what we are talking about. How to calculate the optical resolution? That's a good question. So optical resolution, it depends on several parameters, and it includes the sampling. So first of all, like how you take your pixels, but also the RMS spot radius that you have like in the optics. So you have to take that into account. It depends on the design of the optics. And here, in some cases, even if you have a small sampling, but you have a bad optical resolution, it doesn't help. So it doesn't make sense to oversample. So this is actually very often the case. So here, in the case of the macro lens that we were talking about with, for the FX10, the pixel size without binning will be about 10 micron, but with taking into account the optical resolution, the effective optical resolution will be closer about to be 15, 16 micrometers. But here, it's very difficult to know actually what is optical resolution because it depends on the optics, as I said, and manufacturers, they do not reveal really often what is the, the optical resolution of the sensor. They just speak about the sampling, things like this, and that's a problem. But anyway, so this is the way it is done. And a good hint is to use two samples, two sampling, which is like, okay, it is an equis criteria. So you have one sampling, the resolution is twice, typically. How can I use Lumo recorder with the FX17? Here, I invite you to contact us and we will send you the manual. Do you have cooled camera options? Yes, we do. And but the FX10 is not cooled. The FX17 is stabilized, but the sphere camera between 1000 and 2500 nanometers is cooled. The FX50 between 2.7 and 5.39 micrometers is also cooled, as well as the FX120 between 7.7 and 12.3 micrometers. So three cameras, basically they are based on MCT sensors, and in order to be sensitive with a good SNR, you need to cool them at the cryogenic level with a Stirling pump. For my conveyor belt application at minimal speed 80 millimeters per second, I have maxed out the frame rate at 600 Hz to get square pixel and exposure of 1.57 milliseconds. This gives me a DN max of around 1600, as I can only use LED for my application. Does this affect my wavelength readout? So I'm not sure what you mean by readout, but I can say that here the SNR might not be optimal because it is a 12-bit camera. If you are using, for example, the FX17, well, I'm not sure that you are using our camera, you don't say, but if it will be on our FX17, yes, maybe it's written after. How can this be scaled for industrial fast-moving belt for FX10 Plus? Okay, so you are talking about the FX10 Plus. But so anyway, so those are 12 bits camera. So if there are 12 bits camera, it means that the digital information is coded between 0 and 4095. So if you reach only 1600, it means that you see something, you are not blind, but you do not maximize your SNR. But some applications do not require to have the best SNR. How can this be scaled for industrial fast-moving belt for FX10 Plus? I would say you need more light, or then, how can I say, maybe you could use binning, because the binning can improve also the signal-to-noise ratio. Be aware that the signal-to-noise ratio is depending on the square root of the binning parameters in the spatial and the spectral direction. So if you bin by 2, you increase by 40% your signal-to-noise ratio, because square root of 2 is 1.4, so you increase by 40%. Do I need square pixels as only using the 600 Hertz frame rate give me square pixels? No, in some applications you don't need to have square pixels. Imagine you want to sort this, like if it is like a waste treatment. You don't need to keep the aspect ratio. You can take a line here, another one here, another one here, and that's enough basically to identify the material, what it is. You don't need to have a lot of pixels. So here you can identify only, for example, by taking 3 or 4 lines like this over your samples. So you don't need the square pixels. If you want to shoot it after, like with actioners, that's a different story, but then you can combine the hyperspectral camera with a fast RGB camera. Can this VNIR macro lens be used with the Spekim IQ camera? No. If not, is there a macro lens that can be used with the Spekim IQ camera? Unfortunately, no. Because in the IQ camera, the lens which is there is specially designed so that it can accommodate actually the optics which is in there, because in the IQ, in fact, you have 3 cameras. You have the viewfinder to know roughly what you are looking at. Then there is a hyperspectral camera and there is a focusing camera. And the focusing camera and the hyperspectral camera, basically, they need to use the same optical path. So here, the lens has been designed so that it can accommodate these kind of things. So no, it cannot. Does bright reflective stage, like aluminum, introduce some light blinking into the sample signals? Well, it can introduce some stray light. And actually, I would be really careful with that, especially when you have like dark samples and you have a bright background like this, you will have stray light on the edge and things like this. I will not do that. I would prefer to use like a dark background. Will be okay if I use the raw data, meaning not calculating the normalized data with a dark and white reference. Yeah, well, it's okay, but you cannot make a good model with that. Not transferable model, at least, because, you know, like the raw spectra, they are depending on the camera sensitivity, and from device to device, that change a little bit. And it will really be impacted by the incoming light as well. So if you change your incoming light, the raw data, they change. So you can process raw data, but I do not recommend it. Can this scanning system can be adapted for fluorescence imaging? Yes. We actually have customers using that, and I do it myself as well. So basically, instead of having the halogen light, you just put like a UV light, for example, at 365 nanometers, and then you measure with the camera exactly in the same fashion. Since you cannot take reflectance, as you say, because you cannot have the incoming light and the reflected one, then you need to work in radiance, and then here you need to have, as a purchase, as a separate accessory for the camera, what we call the radiometric calibration, and then basically it's a corrective matrix which helps you to convert the raw data into radiance. One of my concerns is that the waterfall and detector view on the screen come out too dark. Every time I take a camera shot, the brightness is different, even though there is no change in condition. Can I adjust the screen brightness, and is there a recommended value? You go to on the right-hand side, like where you have the detector view, you do a right-click, and then you can change the brightness and also the contrast. Also, you can see on the right-hand side of LumoScan or Lumo Recorder, you have what we call image correction, and check if it is enabled or disabled. And then if it is enabled, it might be the dark reference is not valid anymore and the white is not valid anymore and things like this. But yes, as I say, right-click, and then you can change the contrast and the brightness. A second question from the same person. Can we use the same calibration pack for FX10 and FX17? No, because they are not at all the same camera with the same spectral range, so no, you cannot do that. Yes, Spekim YouTube manual suggests to use the one written FX cal pack without specifying a distinction between FX10 and FX17 for the FX17 camera. Yes, because when we actually sell an FX camera, FX10 or FX17, we have 2 calibration packs. We have the one with FX in the naming and the one without FX in the naming. And the one with FX in the naming actually use or enable the triggering of what we call the automatic image enhancement. That means that it's correcting the smile, the keystone, the tilt, but also it is unifying the spectral range between the device in a way that every FX10, they will have the same spectral calibration, first band at the same wavelength, second band at the same wavelength, and so on. And also the same for the FX17, but of course FX10 and FX17, they cannot be based on the same calibration pack. But yes, use the one with FX. If you use the one without FX in the naming, then you get the genuine spectral calibration, and then it is depending on each camera. What is the optimal grain size for fines to obtain the best quality hyperspectral data? Well, it depends what you want to do. It depends on your application. So if you are looking at something microscopic, then you need to use, like, for example, the macro lens. If you are looking at something which is larger, so then you need to use a lens which like a finer, like a coarser, like a pixel size. So it depends on your application. I'm not sure to fully understand the question here. So yeah. Are there any RGB band numbers for each that you can recommend when using the FX10, FX17 camera? We want to take picture of beef. Okay, so it depends what you want to see in your beef. So for example, if you want to look at the moisture, we know that there is a band at 970 nanometers. If you look at the fat, it is more like 930 nanometers. You have some fat bands as well at 1200 nanometers or so. So it depends what you want to do, what you want to visualize. So if, for example, you have two objects and you want to separate them and just see it already from the false RGB, you just put your band where you know that you have spectral differences for your false RGB. But you know, it's not because you don't see the difference with the false RGB that it doesn't have any difference. So we'll be careful with that. I'm curious about the pricing of the Spekim Insight program. Yes, you are curious, and I'm sure the competition as well. And here we have a lot of competitors watching our webinar, so I'm not going to give this price here. But if you contact us at info@spekim.com, then we will come back to you, and then we will be able to quote you. In the casing of the Spekim IQ camera in our lab, in addition to the white calibration reference panel, there is an orange transparent panel too. Is it for absorption spectroscopy purpose? No. It is here to check what is the spectral calibration of the Spekim IQ. Every now and then, if I recall well, it's every 3 weeks, the IQ camera is actually asking you to check what is the spectral calibration. So here you just need to have the white reference. You put the orange tile, which is transparent at the top of it or partly covering it, and then you follow the procedure to check the spectral calibration, and then it will tell you if the camera is still nicely spectrally calibrated or not. But it has nothing to do with like a spectroscopy purpose. It's only like for checking quality control of the device. Be aware that each camera have their own orange tile because it depends, you know, on the thickness of the tile, and each of them they are slightly different. So here we are looking at really slight, very small differences. So be aware that don't lose it and keep it with a related IQ. What is the narrowest bandwidth that can be practically achieved in VNIR and sphere if you reduce your range sampled significantly? It doesn't change anything basically. Here, the way our camera is working is like there is a 2D detector like this, and then you have a slit, and then the image of the slit is dispersed with a prism and with a spectrograph, with a prism and the gratings, to analyze the 2D detector with a spatial and a spectral axis. So with our VNIR camera and sphere camera, you cannot really change the dispersion, and this is actually what is leading the bandwidth that you have like between each, like the spectral samples, the bandwidth you have between each band. So here you cannot really change it. It is part of our optical design. Is there a reason to put white paper underneath a sample when taking a photo of beef or fruits? What will happen if we put brown baking paper? Nothing. Normally it will not make any difference. You can put whatever background. I recommend to have a darker one to avoid some stray light, but you can choose a background. But I recommend the black one. We would ultimately like to create a model to predict the fat content of beef with FX10 and FX17. It seems that one person likes to ask questions tonight. And that speaking has already done this amazing experience. Yes, actually, I made this technical note. But can you give us any information or protocol on the calibration condition for this? For example, speed, frame rate, exposure time, distance between the sample and the camera length, region of interest, etc. No, so here basically it was for mincemeat. And here the thing you have to consider is like you don't need to be too close, because basically if you are too close, your pixels, they will be only made of fat or only made of protein and things like this. So when you are a bit further away, your pixels, they give you a better overview somehow of your mixture of your samples. So that's one thing. But here I would say what is really crucial, you have to take into account your calibration samples. Like, you need to be sure of what they are. So if, for example, you make a regression and you say like this sample was containing fat at a level of 5%, and you know that only with like an accuracy of plus minus 2%, you cannot make a really accurate model. So you need to know accurately your calibration sample, and then you need to have them as much spread as possible over the full range of the variable you are looking at. So for example, if you are looking at fat samples at about 20%, and your calibration samples, they were all between 5 and 15, you will not get good results at about 20%. So you need to have those calibration samples, which is covering the full variable range, and also to know them really accurately. How can I get rid of glare on a fixed image, for example, if the object is liquid? You could use filters. Yes, you could use filters to get rid like this of the glare. Otherwise, what else? You could have a more diffuse illumination. So that's what comes to my mind. You can change maybe the geometry of your measurement as well. You could do these kind of things. Does Spekim IQ needs dark calibration? In the tutorial in your YouTube channel, there is no mention of the dark reference. It's taken automatically, and when you acquire an image with the IQ, actually you have the shutter which is triggered and taken automatically. Can the Spekim IQ be adapted for fluorescence imaging as well? Yes, it's possible to get the radiometric calibration for the IQ, which is going to be taken as the center line. So here you have to make the hypothesis that it's representative of the radiometric behavior at every part of the front objectives, but yes, it's possible. After changing from 38-degree lens to macro lens, so we are talking here about an FX17, to collect radiance data, we need a new calibration file. Well, yes, because basically the radiometric calibration is depending on the front objectives that you are using. So, because it takes into account the transmission of the optic. So if you change a lens, you need to have a new radiometric calibration. We don't have an object used to focus the camera, as shown in the Spekim YouTube. So we try to rotate the part on the camera lens to temporarily focus it as shown in the manual, but it seems to have limitation. Do we need to buy that object in this case? No. When you want to make like focus, you just put the camera at the distance you want to work with, and then you put something which has a contrast along the line that you are looking at. So something bright with something dark, and then something bright again, or the opposite. And then you try to adjust the focus so that the transition between the dark and the bright is as sharp as possible. So this is a way to do. Can I use a visible camera with a microscope? Yes, we have a C-mount adapter. And with the C-mount adapter, if your microscope is having like a C-mount adapter as well, so then you can put the camera on it. The only thing you have to take into account is like, what is the transmission of your microscope? Is it really between 400 and 1000 nanometers? So does it stop at 700 nanometers? We had customers telling us that the camera is not working after 800 nanometers. Well, okay, if the optic of the microscope doesn't transmit, you cannot get any signal. And you have as well to take into account the illumination. And typically for microscope, it is based on LED, which are not hyperspectral LED. So you have to take this into account as well. Finally, keep in mind that our camera is a line scan device, so you need to have also a movement with your microscope. But yes, we have, and actually, if I recall well, we just published on our blog, on our website, like a success story about microscopic use of our hyperspectral camera. For the mid sample, is it better to use FX17? Well, it depends on what you want to do. It depends on the requirement of your customer. If you want to sort the fat from the meat, FX17 will give you good results, but FX10 as well. If you want to detect some contaminant, FX10 might be better for some, FX17 might be better for some others. It depends what you want to do. I don't have a straight answer like this. And it depends as well on the requirement of your customers. If it needs to be like 100% detectability or 95 or things like this. So it depends on that as well. Does vibration affect the performance of the results? Is it possible to use this camera in factories that now have some vibration in the production line? Well, there is vibration and vibration. So basically, if the camera is shaking constantly like this, keep in mind this is optics, and there is also some gluing, some optomechanics, and this typically doesn't like that much vibration. But then if you have a machine and you have a conveyor belt and you isolate the camera from the conveyor belt, mechanically speaking, then it's fine. And actually we have many of our cameras which are used like this for industrial application at the top of a conveyor belt. Is it necessary to calibrate this camera, or there is no need of that? If yes, how frequent? It depends what you are talking about calibration. If you are talking about spectral calibration, this is done at Specim. You can check it by measuring, for example, with a spectral lamp if the peaks are located at the right place or not. Then we can speak about like radiometric calibration. And here, radiometric calibration, we recommend to do it, for example, every year, maximum every 2 years. And then finally, there is like the white and the dark references, which is not really a calibration, but I would like to speak about it here. So it depends on your application and your requirement. In some cases, you need to do the white and the dark references more often. It depends on your model. It depends if your setup is resistant to the ambient light and things like this. So how frequent it is, it depends. It could be, for example, every day, every measurement, or like once a month. I am studying transmitted light through sample alongside reflectance. Either a plugin for absorbance or transmittance. How can I analyze this data on Insight? For transmitted light, we don't have a plugins, but basically you could consider that the reflectance one is kind of the correct one, because basically when you do absorbance, like in transmission, you make the ratio of what is transmitted compared to what is incoming. And here I would be curious to know how you actually do the white referencing for the transmission. I guess you are using maybe some opal glass as a white reference. So here basically the formula is the same. So here you could use the reflectance plugin as well. And in Insight, for Insight it doesn't matter if it is reflectance, absorbance, a spectra is a spectra. So from that it's able to understand it. Is it possible to rent a camera? Please contact our sales team, info@specim.com. For how long we can take consecutive image with your camera? Is any cooling device needed, or is there any limitation like that? No, and I would say it depends the size of your disk. So if you have a hard drive which is able to acquire like gigs of data, there is no problem, the camera is just transmitting. Then about the cooling, it depends if you are talking about like the thermal camera, or the one which require to have like a cooling for the detector. Then of course, yes, it's better to put the camera into a temperature stabilized casing, but again, it's just to keep the radiometric behavior of the camera constant, but otherwise the camera itself can work. For mineral product, do you recommend the FX10 or FX17 or both? It depends on your product, it depends on what you want to look. For phosphate, for like iron-related like minerals, things like this, it's better to use the FX10 for rare earth element as well. Then if you are looking more like for some other one, which is like geologically different, then you may want to use the FX17, but I would say for geological applications, the sphere camera is actually really good, between 1000 and 2500 nanometers. Then there is also the FX50 and the FX120, which are the thermal ones. So it depends what you want to do, which type of minerals, what you are interested in. And actually, you should go to our website, and here you could check under the geological application, you can check which camera will be matching the best depending on your mineralogy. Is it possible to use this camera on drone for field scale studies? Well, we have the AFX10 and the AFX17 for that, which are basically dedicated for UAVs. They require a payload of about 2.5 kilos. And those cameras include already the GNSS MU unit, as well as the memory card, or let's say the small onboard computer, and the sensor control board as well. So yes, we have two devices dedicated for this. What are the limitations regarding humidity and temperature of the environment in which you can keep and work with the SPECIM IQ? So the SPECIM IQ, yeah, okay, perfect. We have already Harry who is answering. Thank you, Harry. So it's between 5 and 40 degrees and non-condensing. Which software do you suggest for plant phenotyping? Well, you could use ours, like Insight. It has already, inside some vegetation indices, which are already there, like Tecari or NDVI. So this is the one we have. It could be relevant. Or then if you want to extract N, P, and K values, that we don't have. But then I suggest you make your own based on MATLAB or Python. Hello, this webinar will be recorded. Yes, it will. Humidity, already Harry mentioned. In order to get the image, can we use an external device? Yes, the camera could actually be externally triggered. So FX10, FX17, basically all our line scan device could be triggered externally so that you can use an external device like this. By normalizing data, you mean pre-processing using PCA? No, by normalizing data, I mean checking for each wavelength what is the reflected light compared to the incoming one. And here basically you take the data, you remove the dark, which is basically the noise of the sensor, and you divide by the white where you remove the dark. And the white, it is the incoming light. So basically you make the ratio what is reflected compared to what is incoming. And then you get your data from raw data into reflectance, and reflectance they are then in percentage. Thank you. So thank you very much for all these questions. I have to say for me it was quite hectic this evening, but that was good. Thank you very much to all of you. I hope you liked it. I hope I answered your question correctly. If not, again, please you contact us again at info@specim.com. And I wish you to have a nice day, evening, night, morning, breakfast, whatever it is. And yes, thank you very much. Bye-bye.